Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and his brother Joel Chaiken. We are here to help you understand how to approach SAT math questions. Last Thursday, we promised we would do Throwback Thursday, where we go back and find a question from about 20 years ago. But we couldn't do last Thursday's Throwback Thursday. So today, as a special treat, after we're done with this one, we're going to do Throwback Thursday, even though it is Monday. So if you don't want to see Throwback Thursday, just stop the video, of course. Okay, anyway, here's today's question of the day. It is from a calculator section of a practice SAT test. Okay, we have a graph. The complete graph of this function is shown in the xy plane. Which of the following are equal to 1? Wow, okay. F of negative 4, okay, F of 3 halves, okay, F of 3. So you have to know what this notation means. That's essentially what I always like to look at the question and say, what are they asking? What do they want you to know? Looks like they want you to know two things. What does this notation mean? What does this mean? And also how to read a graph. And also not only how to graph, but what does the graph really mean also? But really, what does this mean? And this is function notation. This means what is the output of the function? What is the output of, I'll say f of x, of the function when x equals negative 4, when the input is negative 4. So, whenever you have to read this, then this is the function. They give you a graph of the function. And then you have to basically plug in these numbers into the function. Like negative 4 is here. So f of negative 4 is 1. When the value of the function, when it's 3 halves, is 1.
Yeah.
And then the value of the function.
Well, you could see that the value of the function at negative 4 is 1 because there's the 1 like
right.
there.
Right. Yeah, I'll clear
now
my
move
things.
on. 3 halves. Let's mark where 3 halves is. 3 halves is 1.5. One and a half, x equals 1.5 is here. So you just go up to the line, and the value is the location on the y-axis of the point on the graph. So the value is also 1 here. So Joel figured out that this equals 1. I just figured out that this equals 1. And what's f of 3? We find x equals 1, x equals 2, x equals 3. Oops. Clearly, it's this point. The y value on the y equals f of x is it introduces x and y as the names of the variables. So we see f of, let's see, x is 1, 2, 3, x equals 3. So y is also 1. So all 3 of them are 1, which is answer D.
Right. Okay, so that's pretty standard stuff.
Yeah.
You do have to know what 3 halves means. Maybe the calculator can help you with that.
Yeah. No, I remember. Gosh, I remember. Oh, gosh, maybe around 6th grade, maybe 7th grade. I just did not know what functional notation was, anything what it was about. So, right. I looked at math books, and I saw things like f of x and f of 3 halves, and I had no idea what these things, what these meant. I didn't even know how to pronounce them. F of x or f of 3 halves. I saw this in math books. Say, hey, what does this mean? I had no idea. But then, sometimes 7th, 8th grade, they taught it in school. Oh, it's pretty simple. Yeah.
Yeah,
okay.
Once you know it, yeah. It's very common that function notation is introduced, and you're right. The first time you see it, the first few times you see it, you have absolutely no idea what it is. and then you learn
yeah,
it, and then
yeah,
then you do it enough with enough practice, you sort of know it. It sort of becomes in
yeah.
your heart. Okay, everyone. So please give us comments, like us, dislike us. Let us know how we can make these videos better. I think we're done with this question. Boy, that was fast. So
Yeah.
let's do Throwback Thursday, but observed on Monday. So in order to do Throwback Thursday, we have to bring back a test from like, oh God, 2001. So you can quickly see like these tests look very different. They have these weird sections, and then here's a math section. Let's see,
Mm.
but we have to find a question that like you'll never see on a current test.
Uh,
So they have to quickly go through. Oh, this is the one we did last time, right? So we have to go through and find a question that you wouldn't see. Oh, this looks weird.
oh,
This looks weird.
oh,
Oh yeah,
okay.
well this could happen, right?
Yeah.
This could happen on the current test, right? Is the which lists the numbers in the average mean less than the median? What do you think? Can we
Yeah.
give that one a
Let's do
shot?
this one.
That one looks a little different from a current SAT question. It certainly
Yeah.
has a lot more numbers than.
Yeah. We did one like this with the mean of the number of siblings
Yeah, yeah. So
that high school
right,
students had.
right.
Okay. Oh,
Do you want to do that one?
yeah, sure. Let's do that one. Yeah.
Okay. Well, I don't know.
Yeah.
This one's a little more different.
Oh.
This one's a little bit more
Oh.
different. First of all, it has 5 answers as opposed to 4. And
Oh.
yeah, how about this one? Because this one feels different from a current test. We're gonna have tons of extra questions to do. So maybe we should do this one. Okay. Okay. If those things equal 0, what's the following can be true?
Yeah.
Okay. Oh, I see. This one isn't that bad. This one actually isn't that bad. It just has a different feel to it because it has 5 answers.
Yeah. Mm-hmm.
So, well, it's very similar to a question we actually did related to the zeros of a polynomial. When, either one, in order for it to be 0, this can be 0, or this can be 0, or both can be 0, right? M can be 0, or k 1 minus k equals 0, or both, right? That's the only way.
Wait a minute. You're not plotting it right.
I know. Forget the plot. Forget the plot. Let's just do it algebraically. Let's think algebraic modality as opposed to. So m can be 0, m minus 1 can be 0, 1 minus k can be 0, or both. M minus 1 or 1 minus k can be 0. That's the situation that makes that 0, right? So can m be 1?
Well, I think so. I'm worried about the logic.
Really? Okay.
So, they tell you to assume that m minus 1 times 1 minus k equals 0.
Yeah, that's an if. That's right.
And then, which can be true? Well, m minus 1, m equals 1. That can be true.
Yeah.
By taking, we could take k to be anything.
Right.
And m is 1.
Yeah.
So okay, the two of them, the product is 0.
Right.
What can be true? So in other words, we rule out the ones that cannot be true. Right? For example, one that cannot be true is m equals 3 and k equals 7.
Right. Yeah.
Right. Yeah. But what can be true? Well, m equals 1 can be true.
Of course.
Because if you could take m equal to 1 and K to be anything, and you'll get 0. That
Right,
can be
right,
true.
of course.
Similarly, K
Yeah,
equals 1. That
right,
can be true.
right.
But now M equals K. Can that be true? Well, if M equals K, no, sorry, that is, let's see if it can be true. Well, if you pick K and M both 1, you'll get 0. And so M equals K can be true.
Right. Well, that is so tricky. Now,
It is so tricky, yes.
unfortunately, I don't have the answers. I don't have the
Yeah,
official
yeah,
answers to this test.
yeah,
I only have the test. So we
yeah,
don't know which one the actual SAT says the answer is.
yeah.
So yeah, wow, that is
Yeah,
tricky,
that's
right? Which
right.
of the following
So
can be
the
true?
problem would be different. The problem will be different if they asked which of the following, and they gave some properties, must be true.
Yeah.
What must be true is M equals 1 or K equals 1.
Oh wait, I do have the answers. I do have the answers.
Okay, so what do they say?
I do have the answers. So you're saying that it's E.
Yeah.
Okay. Wow. I just hope I get the.
Well, let's
Actually,
see.
I have well, just to show everyone how complicated they used to make the SAT. This is section 2, question 12, right? You gotta people. If you haven't seen an old SAT, good luck.
Uh,
This is their answer sheet. Notice there are 7 questions.
uh,
Here we go. Section 2, number 12, E. Right?
okay.
That was our question 12, right?
Okay.
E.
Well, it's cool. Wow.
Wow, look at that
Good.
difficulty level.
Yeah.
Oh, look, we picked a good one. Difficulty
Yeah.
level 3. Oh,
Yeah.
look, wait. They even have a 4. We have to go back to the answer sheet and pick a 4 next time.
All right.
Yeah. Yeah.
All
Yeah.
right. So next time we'll do a 4?
No, this Thursday we'll do a 4.
Okay.
Yeah. Wow.
All right.
That is nasty, right? You don't see that.
Yeah.
You don't see that as much. Notice the 6 or 7
Yeah.
sections on this SAT. Yeah, that's pretty tricky, right?
Right.
Let's see.
In fact,
Question 12,
let's see.
yeah. Wow. Ouch.
Yeah. Yeah.
Ouch.
And in fact, if they changed it, if they changed can to must, then the answer would be A, none.
No, if it's must, then wouldn't it be D, 1 and 2?
No.
No, which of the following
No.
must be?
No,
Oh,
no,
you're
no.
right. Oh, you're right. Oh, you're
Yeah.
right. You're right. Yeah. Wow, that is rough. That is
And
rough.
then they could also, another logical variation is which of the following imply
Yeah.
that m minus 1 times 1 minus k equals 0.
Yeah.
In which case, 1 implies that the equation is satisfied. 2 implies it's satisfied. But m equals k does not imply it.
Mm.
A counterexample is pick m equals k equals the common value of 2.
Right.
Yeah.
Yeah. Wow, that is.
So this is a careful. This is a question about subtlety in logic.
Right.
And what the words mean logically.
Right. That's right. Yeah.
Yeah.
Yeah. And we notice that it's really not part of the curriculum of this new post 2016 SAT.
Yeah.
So if you're sitting there, oh my God, I can't stand this test. Just you're lucky you weren't taking it 20 years ago. Because you would have had a lot more.
So again, what we can carry over to the modern SATs is pay attention to what the words say and interpret the words very carefully and correctly. And like, distinguish between words like can and must.
Yeah. Yeah.
Yeah.
Yeah. Yeah. Definitely. Yeah.
Yeah.
Okay, so that does it for Throwback Thursday, observed on a Monday. And we'll always give you a Throwback Thursday once a week. Hopefully, we'll do it on Thursday because that makes logical sense, right? Logical sense. Okay, so have a great day, and we'll see you tomorrow.